All right, 8-3, day 2. So now we are going to look more specifically at how we can use the standard form of a function to help us find the vertex and how we can compare different forms of quadratic functions. So in this case, we're looking at a table. The data for fountain B was given to us in a table, and we're comparing it to standard form. Later, we're going to do one with a graph in standard form, and then we're even going to look at the two different uses of vertex form and standard form in example 4. So, if we're comparing the vertex of each function, which technically means we're trying to find the height of each of the fountains, we're going to need in fountain A to use that negative b over 2a form. This is going to give us, remember, the x coordinate of the vertex. So if I plug in negative b over 2a, I get negative 2 over 2 times negative 1. And I solve that. That's negative 2 over negative 2, which equals 1. Then, in order to figure out how tall this function is, I'm going to plug that 1 in to get my y value. So f of 1 is equal to negative 1 squared plus 2 times 1 plus 8. Negative 1 squared is negative 1 plus 2 plus 8, which is 9. So the height of this fountain is 9 feet. Then when I look at fountain B, they're giving us a table. When I'm looking at this table of values, I can see where this vertex is because remember, these ordered pairs are symmetrical. So it's going down 3, down 2, but then it goes back up 2 and up 3. So we can find that that vertex is that point located right there in the middle. So the height of this fountain is located at 410, which means this fountain is 10 feet tall, which is the taller of the two fountains. Okay? In the try it gave you a function in standard form and a graph. So the graph is pretty easy. We just had to look at the vertex of the graph, and it was located at point 3, 0. So the height of this, I think it was a fountain also, is 0. And then we had to find the height of this function. Again, we're going to still use that x equals negative b over 2a. Okay, this time, because my b value is negative, I end up with a double negative 0.6 over 2 times negative 0.3. So that's really positive 0.6 over negative 0.6. And so my x value is negative 1. Now plug that into my function. Negative 0.3 times negative 1 squared minus 0.6 times negative 1 minus 0.2. This ends up being negative 0.3 plus 0.6 minus 0.2, which is 0.1. So my vertex is negative 1, 0.1, which means that this fountain would be 1/10 taller than the graph function. Okay, so looking at the vertex will tell us that minimum or maximum point. So sometimes it's the height of something, sometimes it's the depth of something, depending on what kind of function we have. Now, the next example was Mia, and she was throwing a ball for her dog, and basically they gave us the function of the trajectory of the ball, and it was negative 0.5 times the quantity x minus 2 squared plus 8. Well, this negative 0.5 is our a, and this tells us that our function is going to open down because a is less than 0. It's negative. This 2 value is our h, and the 8 is our k. So they were asking us, what does the vertex form tell us? Well, it tells us the vertex, which will tell us the height of the ball. So the vertex turns into this ordered pair 2, 8. Remember, it's positive 2 because this is the standard form, has the negative sign in the formula. So it's a positive 2. And what this is saying is that the ball has a maximum height of 8 feet when it is 2 feet away from Mia. So the ball has moved over 2 feet and it is at a height of 8 feet from where she threw it. Now, if we want to know where the ball started from, we have to move this function to standard form. And to rewrite it in standard form, we have to multiply out this x minus 2 squared, distribute the a into that, and combine any like terms. So, if I multiply x minus 2 squared, remember that is x minus 2 times x minus 2. And when we do that, we use the double distributive property, just like topic 7. So this stuff is going to come in handy a lot. I end up with x squared minus 4x plus 4 at 8. Then I have to distribute this negative 0.5. Oops, that should be plus 2x minus 2 plus 8. And then I combine my numbers over here, which are my like terms, to get negative 0.5x squared plus 2x plus 6. So when this is written in standard form, we know what the y-intercept is. My c value here, 0.6, tells me that the ball was 6 feet above the ground when she threw it. And I'm going to say the ball started 6 feet above the ground. When she threw it. I said started because usually the y-intercept is our starting point, and so we can use that vocab. Okay, now there was one more try it. It was basically the same thing, just saying what if The function for the trajectory of the ball was negative 0.25 times the quantity x minus 1 squared plus 6.25. I want you to tell me the vertex and what the vertex means from vertex form, and then I want you to rewrite it into standard form and tell me what does the y-intercept mean. And then you can check your work against mine with a copy of the notes. Also, I did have the concept summary taped up here. You can either print that and tape it as well or copy it into your journal also.